Hi everyone, Zach here, and welcome to lesson 61 in this series on developing a survival game. In this video, we'll finish setting up our custom volumetric clouds with a particular focus on our phase shift. This video and this series have been brought to you by Patreon sponsors, and you too can support this channel, and all you have to do is hit the like button down below. And if you've not already, make sure to hit the subscribe icon as well and turn on all notifications. Alright, open up your projects, and we'll make a start. Hi everyone, welcome back to the engine, and in today's video we'll be finishing out our custom volumetric clouds. Hopefully this will take much less time. I am going to go directly into my materials, go into my weather system, go into my cloud folder, and open up my custom clouds. Alright. So what we're going to do is we're going to add in a two-part movement system. So the first part is the clouds themselves moving and the clouds then shifting with time and as they move. So they'll break up, they'll reform, they'll do other things. So we're going to have a little bit of some, variety to our clouds. And then we'll explore the various parameters we've set up before we're actually creating the function that will replace this. So it is a lot of stuff to do, but it's fairly short, fairly simple, I hope. So let's start with panning our clouds. Now, we can't just simply put a panner node in. This is a volume texture. And a volume texture is a 3D texture, it's a cube really, of different slices of noise. That's the Perlin noise we have in there. So if we were to open this up and go through it, you'd be going through various, it's honestly the only way I can explain it is from back when I did my MRI training during my PhD. It's like going through a slice of a brain at a particular angle to get a different effect. That's really what it is. It's a voxel. It's a set of voxels clustered together, and we're cutting different slices to create an image of something. We're pulling a texture, flat 2D image, from a 3D object, and we're doing this at different angles and at different depths. I'm sure that made sense to nobody, except for a couple of people. I really can't find a better way to explain it. If anyone has ever done anything and knows anything about CAT scans, MRIs, anything where slice angle and depth matter, that's all we're doing with this. We're cutting through a cube. Imagine you have a piece of Play-Doh near Play-Doh, and the Play-Doh is, multiple pieces clamped together and jumbled together, kind of like how that looks like different colors of Play-Doh cut together. And you were to slice it into different segments, and you could pass through each segment. That's all this is. We're passing through different segments of this thing. Now, we can't just pan through that, so we have to find a different way to move it. And the way we're going to do that is we're going to change the UV coordinate we're looking at, like we normally do with panning, but we have to control how we're slicing it, how we're moving it. So the way we do this is we start with creating our panning noise on a virtual texture, and we need a make float 3. And the reason why we need to make float 3 is we're going to move through the X and Y values, so our left and right values. Our Z value, which is up and down, we don't care about. So we're going to hit 1, leave it at 0, and plug that in. And that's because we do not move in the Z axis. We do not have the clouds moving up and down. That'd be kind of interesting to see. If you want to do that, well, this is where you do that. We are then going to create two parameters, and we're going to create one for X, which is our speed X, and we're gonna leave this with a range of, just for sanity's sake, -1 to 1, and I'm gonna default this out to 0.2. All right, and then I'm gonna do the same for our Y, and this will be our speed Y. I'm gonna leave the default at 0, but I'm going to again give myself a range of 0 or -1 to 1. So this is what's really controlling the left and right movement. So we are controlling left, right. I'm going to call it panning, even though technically it isn't panning. We're cutting through a cube. And then we're going to control this. And what we're going to do is we're going to do a multiply, again, just like we controlled down here with a multiply. And we are going to reverse what we have that. We're going to do a divide off of our control. This, I think, is closer to how we did our tessellation. I can't remember, though. And again, we want to work with large numbers, again, because we're dealing with the sky, but not gigantic numbers. So again, I'm going to create another parameter here, or not parameter, scalar value that isn't a parameter, and set it to 100. So whatever I put in A is now, sorry, small values. We want to make really small values, not really large values. We want really small values. So we don't have to work with those small values. We're going to divide it by 100, and we can use what I'm going to call, quote unquote, normal values, and we will promote the A variable to movement speed, and this is the overall movement speed. That's why it's the control. And for this, we will default it out to 2. If it will, wow, okay. I had a bit of lag there. Really quickly, I'm just gonna add these into a new category called movement. And you can see why I'm categorizing them with how many variables we have. Yeah, and I wanna make sure that nothing is, oh, okay. Well, this will go into altitude because I have no idea where else to put that. And this will go into master. There we go. I think they're now all categorized. Yeah, they are. Not that the categories really matter outside of ease of readability. So again, this is our control, and we're going to do a few things. We're going to take our time. We can't use our game time, unfortunately. I don't know. Actually, yeah, there are a couple of ways to get it in here, and we can talk about that in a later section. I just worked out how to do this. But we're gonna multiply in time, and we're gonna move that into our beta value and just type in time and put time into our alpha value. I'm going to leave ignore paused undone, and we're gonna leave the period as the default period. If you really feel like it based on our game time, we could put in our game time, but we'll be doing that. We don't have our game time set up yet, so we'll talk about that down the road, probably towards the end of the series, assuming I remember my comment on that and my solution. Sorry, I'm trying to line these up real quick. And then we are going to also take this and multiply this, thanks Unreal, by a value that will just slightly increase it. So we want to increase it by about 5% of whatever we've put in. So to do that, hold on 1, click in, and you don't put in 5. That multiplies it by 500. We want 1, so it's 100%, 0.05. That's 105%. So can potentially replace with our game time. I'm just going to put that note there so we can potentially replace that with our game time. And now we need to add these into our clouds. And I'm going to move this way just for a moment. And this is a multiple step process. So first we're going to work with this one because it's the easier of the two. We're simply going to do an add node. And actually this is going into plug that into our UV. Let's plug this into our B. I'm going to plug this into A. It's add. It should be added. It should be follow the additive principle. And our B value is going to come from, our B value is going to come from our time control up here. So we're going to take this multiply and come down there. And again, I'm going to just start moving this to the left a bit, just so it's a little bit easier to work with. There we go. And I'm going to put a reroute in here because we're going to have, I think, 3 things coming off of this one, according to my notes. So we're done with our one down at the bottom there. Really quickly, I'm just going to expand this out. And I'm going to comment out this real quick, as this is our tiling. In fact, actually, the tiling starts all the way over here, but I will leave that separate. All right, so for our next one, for our details, we're going to have another add, of course, and we will go again into the A here. The A will then, or the result of this will then go into a third add, or second for this line, and this add will go into our UV here. All right, so for our B, and this one's going to be a little bit different. We're going to actually have to multiply in these two. This is our detail movement. This is our general movement. We're going to have to add them together. And the way we do that is via a multiply. So we only have 2 things coming off of this. So I will do multiply. And our B value for our multiply will come from our detail control down here. And our A value, our alpha value, will come from our time control. All right, so we now have that kind of set up. Now I'm curious about something because that color does not match what's on my other screen. I am going to just quickly switch these around to see if that actually does affect anything. It didn't seem to. Interesting. Okay. I'm not going to question. Oh, no, it does. Wow, it did. Okay, so this does have to be in B. All right, that has to go into our A. We do need a little bit of a different color there. I'm just going to mess with the tiling a bit. See if the tiling is affected in any other way that I haven't accounted for. Yep, it does affect the tiling just a tiny, tiny bit. So we'll leave it at 30 for now. What we need to do then is we need to start working on the way our clouds are going to shift. And we're going to use this value here to shift our clouds. So to do that, what we're going to do, also I might be just completely wrong about that A versus B because they are changing color and I'm using the color. I forgot this is a live update. you know what? We'll leave it as is. In fact, I'm going to switch these around so I follow my original version. The multiply will come up here. This will go into A. That will go into B. This will still go into A, don't worry. So now we need to we need to move our clouds. We're going to use the mathematical formula for phase shifting. I'm not entirely sure how to explain how phase shifting works, so blah. And Wikipedia, that's all I'm gonna say. We're gonna do a divide, and we want a really, really, really small number. Unlike here, though, we're not gonna use 100. But what we are gonna do, actually we could use 100 and use slightly bigger numbers. Yeah, we'll use 100. We'll plug 100 into here. We'll then create a new scalar parameter called phase shift, which will go into our movement category. And I'm going to give this a value at default of 2. So hopefully I've done my math right here, and I'm going to double check my math just in 1 second. So my calculator says that I have done my math correctly. All right. So really this is going to cause our clouds to break up. We're going to then multiply our result here. And this is where things get a bit complicated. So what are we multiplying it by is our actual cloud position. So we're going to take our RGB value here and plug into our A or our B there. And then we're going to take the result of this and add this in down here. So this is our very confusing phase shift of clouds, and that is our entire movement system. So I'm just going to select all those nodes, comment them out as movement. I apologize for that last bit. I've honestly spent a while trying to work out how to do that. And if we go over to our game in just a moment, it's going to be a bit weird depending on how this saves. Oh, hey, I didn't do the weirdness. Sometimes it'll do weirdness. But if we hit play now, okay, we should be able to see some movement. I'm going to just get slow-mo, and I'm going to put 5 in. We aren't getting movement. Something has gone slightly off. Okay, so let's work out what's going on, and then, yeah. Okay, so it is working. As you can see, the clouds are moving. I don't know if I've typed something in wrong. All I did was change the movement speed from 2 to 10. This really should be at 2 based on what I'm doing, and it should work perfectly fine. I'm not sure why it wasn't working. We will put this at 10 for now. I'm gonna actually we'll leave it at 2. We're gonna leave it at 2 because that is what I have as my default value. I'm trying to keep to my default values as much as humanly possible. So we finished the material out. We just need to set the parameters in the instance. So we change the emission based on time of brightness of the sky. We have 2 different colors based on extinction. We have our volumetrics that I can't explain to you. We have our clouds. Also, I'm gonna add this in for movement as a comment, where we take on the top line here a detailed set of the texture, and then on the bottom the general set. We combine them, we set our density. Then we have our movement, by the way, which gets added in. The reason why this goes into our phase shift is we're shifting our details based on our overall. So what we're going to do now is just save this all, create a material instance, and then explore these parameters somewhat. So what I want to do then is go to my main window here, right click, create material instance, select my volumetric clouds, move the material instance in there, and then I'm going to open this up. I'm going to move this to a different window for a moment. In this window, I'm going to hit F11 so it's full screen. And then I'm going to bring this back onto this screen. We definitely do not need our overall picture because it's a volume. We don't get a preview. I'm just going to slide it that way. And let's just go through all of this in terms of our settings. So I'm not going to change the altitude. So if we do, nothing really happens right now. We'll talk about that in a moment. We'll explore that differently. We'll explore how that works in a different part of it. For our details to add, I am going to leave this at the default value of 1, but let's just really quickly change that. That is a fairly powerful node, as you can tell, like I said in the comments. We have our detailed tiling, which lets again play with that setting. So we can select that and we can change. You can see that if we move up just a little bit closer. Again, if you want to get really close really quickly, you can just up this. So we're a bit closer. That makes this a little bit easier to see what we're doing. So as we change that, you can see the details around the clouds becomes a little bit more tiled, and we can change just how that cloud looks. The higher it is, the smoother it's going to look, a little bit more cartoony. The lower the value, the more broken up it's going to be. I'm going to leave this around 40, which is our default value. Actually, kind of maybe at 35. Let's go back to 40. Mostly because I don't know what my primary cloud tiling is going to be at. So let's take a look at this one. If you change this, it changes. Ooh, you can see a lot of tiling right there. You can see it over there as well. So the higher the value, the greater the tiling is seen. Same with the lower the value, it's even really kind of obvious there as well. Even more so. Very old school sort of PS1 vibe clouding. So I'm going to just kind of try to find a value that I like. I think around that area. I'm going to just round that down to 40. For our detail contrast, actually let's go back to our tiling real quick for our detail. And now we can see what it looks like at different set. You know what? I am just gonna go with the default. For our detail contrast, let's just play with that number. And that's what's happening when we add in that detail contrast. So if I look up here, you can see how it's really dark and kind of gloomy. Well, if I lower the contrast a bit to -1, it's completely gone. We just got the floating gloom clouds. I set it to 0, we get that. If you just keep playing with it, we can see how it just sort of adds in more and more contrast. I'm just going to leave it at the default setting, mostly because, yeah, we can change these down the road. For our cloud contrast, well, for our cloud contrast, sorry, I had to double check where the cloud contrast was in my thing. What we're going to do is just play with this one for a moment. And you can see that it's adding in contrast against the sky and fading it out as we go higher. We don't want to use this node, really. I really, really recommend avoiding using that node where possible. I want to have some real fun, by the way, and I can't remember what I did to do this. I got this to be a very Van Gogh cloud effect, but I changed my extinction color, I think to... Oh, let's just see if we can do this. I think I went to a very dark blue, and then did my primary color as a red. There you go. You can see where the primary color fills in now and how the lighting affects it. So the less light coming through it, notice the darker parts of the sky. Notice the parts that here on the edge are red are the parts that are being hit by the light. Whereas the parts that are blue, and let's actually go to, say, green for a moment just to make this a little bit more noticeable. You can kind of see faint green on the outer edges there. That's the parts the lights aren't passing through. That is so creepy looking. Anyway, we're gonna just revert back to our default colors here. That's why I picked them. These default colors are the colors I want to use. So notice where it's passing through, we get that more grayish white. For our extinction scale, if you just change this, it's higher it is, the sort of more of a harsh line you get between the two. I'm gonna go back down to 0.5. So it's a bit softer and fuzzier around that line. Our emissive value, well, it's daytime, so we can't really see it. But what we're gonna do is hit Control L, and just lower the clouds. This is the emissive value right here. Let's just turn this off for a second. The clouds are still there. We just can't see them. This is why we have this emissive value. Now let's start increasing this. Okay, so even before I reach 10%, rounded up, that is 10%. That's what happens. That's why that value is really, really small. In fact, I think that is the smallest value we can use before things become, I mean, technically you could go to half the value. I don't like that. And if we double this value, it's a little too bright for my opinion for nighttime. So we're gonna go to that value. And this will also really help, again, with our weather effects. Now, I'm just gonna quickly bring the sun back up. There we go. That's roughly where I want it. I'll fix it in a moment. For our cloud particle density, the placeholder, let's just take a look at what this does. This value doesn't matter. We're actually going to have it default to 0 at the end of the day. So the more clouds we have, it's actually completely overcast. No light's getting in. Let's start lowering it. Really around 0.52 is where we kind of want maybe to max it out. Let's go up to 7.5. At 7.5, yeah, you can see some contrast, but it's really hard to see it. Go down to 0.6. Again, the contrast is there. It's a little bit more visible. You're clearly overcast. Maybe 0.6 is where we want to max this out at. But you're going to use this value to figure out where your max is. The min is 0, by the way. No cloud cover. Like cloud cover. All right, let's set this back to 0.5 just so we have some clouds to look at for the testing. Let's look at our overall density. Again, this is actually extremely powerful. Again, now we could use this as well to create some really thick storm clouds. In fact, actually, I think we might do that. I kind of like that. And we'll come back and talk about that in the weather system in a bit. That is really nice. I like that sort of black wall of cloud. What happens if we lower this down just a bit? Ooh, those work really well together. All right, so we're gonna use our overall density and our density together. This mat will become a placeholder because I did not explore using this. For our movement, well, let's just increase our movement speed to say 100 just so you can see it. There we go. We have some fast moving clouds, and as they move you can see they're breaking up and reforming. So I'm going to just set this back to 10 for a moment. For our speed and y, I am going to set a value here. This I will set to say 0.3. And the movement's a little bit more clear. I'm gonna go back to 2 on this. Yeah, I'm a bit concerned that time isn't working the way I expect it to. We will hopefully figure that out during the day-night cycle part. I am gonna leave this at 10 for now, just because I want to be able to see my clouds moving. Fortunately, with it at 10, it does make the tiling a bit more obvious in my opinion. So now we have the volumetrics. The volumetrics, I don't know how to explain these, what they fully do, or anything like that. And honestly, that might be what's messing with my movement speed. So, by the way, if you get weirdness, you get artifacts as you're doing this, let it just finish doing the shaders and the artifacts will go away. So let's start with our phase G, because that is the first one on the list. And what happens is we do that, is it changes sort of the overall way the light affects, kind of like how you can brighten up things on this. And I want to let's go to 0. So it's really dark. Let's go to 1. It's, again, you can see how the light's coming through that. Let's go back to 0. The light, how it again passes through, is being affected. Let's go to 0.65. And now we get that nice sort of clear. We can see the white in our cloud. So I want to stay around 0.65. Try 0.7. It's a little brighter. I don't like the smearing on the, or the scattering on the cloud there, or on the light there as much. It's a very subtle difference on the edges. So let's go to 0.65 for our phase G2. Let's change that. And you can again see, you know what? We're gonna actually set the default movement speed back to 2. Okay, so it's a little bit more stationary as we do this. You can see how it affects the light coming through. I don't really like the effect it has, so I'm gonna set that to 0 for our phase blend. All right, let's see what happens to it in -1, because -1 is really the same as being at 0. So if we go from 1 to -1 to 0, I can't tell the difference. Now, say -0.5, I still can't tell the difference between that and 0. So it has to be a positive number. We're gonna just tinker with it a bit until we find a value we like. I don't like how bright it is, so I do want to get it a bit darker, just a tiny bit. That's a little too dark, so that's 0.2. Go to 0.05, still a bit bright. 0.15, 0.1. I'm gonna go with 0.1 for our phase shift. For our multi-scattering contribution, there is that at the top one there. If we just play around with this, we have to look at the way it affects the light. It's really, really subtle. I want you to look just at the way the light rays are coming through as I play with this number. In fact, I wonder if I boost this up to say 10. You can't see it. It does really just clamp it at 0 to 1. I'm just gonna give you that I use 1.4. Actually, let's say 1.42. For our occlusion, again, I'm not sure how visible this is. You can see the clouds are actually moving. Again, look right there-ish. It's a very subtle effect. And again, I'm gonna use a value of 0.1024. And then for our scattering eccentricity, first I'm going to move the light a bit just so we have it near some clouds. I am going to, again, move it. You can see the clouds are clearly moving now. Actually, I'm going to leave it at this is the kind of speed I was expecting, so I am glad that they're moving at 2, so I can get rid of that. We were doing eccentricity, I think. So you can see just very subtle changes again with the way that the scattering is being affected. It's extremely subtle. I'm just gonna go with 0.245, actually 2.453. Just because it creates that nicer sort of effect. It's really hard to see. All right, I realize that I spent a lot more time just walking you through all of those nodes than I expected to. Just gonna save everything. For some reason it didn't save when I did Control-Shift-S. And the next thing we're gonna do is we are going to very quickly, and this is quickly, create some material settings we're going to use. So we're going to create a material parameter collection first. And so we'll go to materials, go to material parameter collection. This will be MPC, and this will be weather, 1 underscore, not 2. Weather clouds, or weather cloud. Yeah, I'm just going to call it weather clouds. Horrible name. It's cloud effects, really. And what we're going to do is we're going to have one scalar parameter. Actually, we're going to have two scalar parameters. We're going to have, I'm just going to go back in here and cloud density and overall density. We're going to just go ahead and create variables for that, I guess. So this will be cloud density, if I can get into the right spot. Cloud density. We will default that out to 0 for now. And then we will have our overall density, which I am going to leave at the default value of point. You know what? No. This will be 0 as well. We're going to use this one slightly differently. And this is overall density. All right. I'm, by the way, if you can't tell, deviating from my prep file, which is why I had that moment of, We are going to create we're going to create one new thing, which is a material function. So this will be mf weather clouds. Let's pop this open. And in here, we're going to have this be our cloud density. We are going to find our collection parameter. This will be our MPC weather. Oh, there it is, MPC weather. Oh, I skipped the E. Oh, sorry, the R. Let me go refix that name. I knew something looked weird about it. Okay. Let me move the mouse. Thank you. Or cursor. There we go. All right. So weather clouds now. This will be our cloud density. That just going straight into there. For our overall density, what we're going to do is we're going to do another output node, which is a function output. And this will be our overall density. We are going to pull back from this one and do an add node. And in our A, we're going to have a function input. So we're going to do function input. This is a scalar value. And this will be our default. Actually, this will be our, what did I name it in the actual material, by the way? Overall density. Useful. Overall density. And that's going to go straight into our A value there. For our B value, let's just duplicate this cloud density node down here and switch this over to our overall density and plug that into there. Let's apply and save. Go to our main material here. And in here, we're going to do a material function call. We are going to look for our MF cloud or weather clouds. There we go. All right. This is going to be a bit messy, unfortunately. We're going to unplug the overall density, plug that into here, and overall density goes this way. And we're going to come back over here. I mean, I guess it's fitting that the densities are closer to each other now. Line those up, and we're going to plug this into our alpha. So there we go. Now, if we go back to our map, at this point, we should have no clouds on the screen. There we go. We have set up the controls for our weather system now to affect our cloud coverage. I'm going to lower my settings back to 4, and I'm going to go back to my... Right. Sometimes this happens. I don't know the cause of it. It drives me up the wall. The way to fix it, reload the map. You might need to rebuild lighting, by the way, if this happens. There we go. There's our island. It's back. All right, so that takes us through everything we needed to do, and I did it hopefully in, only 6 minutes less than my last recording. Of course, there is a bit of sneezing I'm gonna have to edit out, but we now have a cloud system. Of course, we can't see anything of our clouds right now because we've set it to be default to a clear, sunny day. As we move forward in this section, that will change, of course. And so in the next video, what we'll be doing is actually setting up our day-night cycle. That is the last bit we need to do before we can tackle actually having a fully dynamic weather system. So that said, we've done everything we need to do for our clouds. We're nearly done. Sorry, there is something else I was going to show you, but I realized the time. What I'm going to tell you to do is explore this. Just trust me, explore this. Plug these back in, plug that back into that one, and plug that back into the alpha there. What I want you to do is I want you to go to your textures, and I want you to, if you're paranoid about doing this, by the way, what I'm going to say is make a duplicate of this, open the atlas up, add in the duplicate as another array, and change, or another curve, and change which curve you're using in here. And then in the curve, what I want you to do, ignoring all the other channels but red, is first play with this. Play with this one here. Move this up, move this way. See what happens. You might need to be up in the cloud layer to actually see it more fully. But what's really happening is that the red channel is controlling the fallout, so it can be more billowy depending on its location. That's really all that it is doing. If you want to use the other layers, depending on how you make your texture, those other layers will determine what you use. So if you do need another set of textures for other layers. All right, that covers everything I really wanted to say. I'm not a texture artist. I'm not an environmental artist. I'm not using all the environmental tools that we have at our disposal to make this environment. I'm a code person. I'm gonna work through logic. So that's why these are a little bit longer and why I probably am not giving the clearest explanations for some of this material stuff, but I'm trying because I'm thinking about it from a coding point of view. But yeah, that covers everything we need to do before we get into our day-night cycle and then into our actual dynamic weather system. All right, as always, this series has been brought to you by our Patreon sponsors like Rian, Hanas, 1Volt10, and Connor. If you've enjoyed working on your clouds and your dynamic weather system, if you're liking how your island is starting to look, make sure to hit that like button down below. And if you want to be here when we work on our day-night cycle, this lightning's still active, the sun's in the wrong spot still, then make sure to hit the subscribe and notify icon. And as always, I look forward to seeing you in the next tutorial, and I hope that you have a wonderful day.